Alright, so these are your stick welding electrodes. These are 7018 electrodes, okay? And if you look at these are actually different sizes electrodes, okay? So this fat rod here is a 5/32 electrode. Okay, this is a 1/8 electrode, and this one is a 3/32 electrode, okay? And the different sizes of rods determine how much metal you can put down at one time, okay? And it's also determined based on how thick the metal is that you're welding on, right? So if I'm welding on thin material, then I'm probably going to want to use a smaller rod. Then when I'm welding on very thick material, I want to use a bigger rod. Or if I got a big groove to fill up, I can use a big rod to fill it up more quickly. Okay? So all of these rods are an electrode positive rod. That means that the electrode holder, do we have one? We have this electrode holder. This holder needs to be connected into the positive side of the machine. Okay? So that means that the electrode, when it's in the stinger, it's connected to the positive side, and the ground is connected to the negative side. So these rods run electrode positive. Okay? Not all rods are electrode positive. Okay? We have some other rods that are electrode negative. I think 6010 is actually electrode positive. Well, there are some rods that can be run positive and negative. And then some that can also be run on alternating current. Okay? So you may run a rod on electrode negative, and that's because it can run both ways. Okay? We have a whole chart that'll tell you whether it's electrode positive or electrode negative. But I think, if I'm correct, I think a 6013. That's an AC rod. So usually when a rod is AC, it's also negative. All right. Do we have? Let's look in the book. Let's just look it up. This is what I tell people to do. If you're not sure, just look it up. Okay. So let's look it up real quick. Let's see. Where are we gonna look up? Electrode selection. Let's see. That's where I can give you the correct information. Here we go. Electrode selection on 111. There's nothing wrong with using a book to look up information, okay? Nobody ever said you gotta memorize everything in the book, okay? So, let's see. So, here we go, right here. Okay? Now take a look. So, if you look here, it tells you, electrode class, and then the last two numbers are like, the rod that we're using. So we know the first two numbers is the tensile strength of the electrode. So if it's 70, then it's 70,000 pounds per square inch, right? So this could be, example, like a 70-20 or 70-27 or 70-24 or 60-28 or 60-12, right? Okay, so we want to look here and see whether it's electrode negative or positive. So a 70 18 is in this category here. It's a fill freeze rod, iron powder, low hydrogen, and it's DC electrode positive, or you can run it on AC, right? Okay, and then we were saying a negative rod is probably like a 60, I said 60-13. So you see the 60-13 is a fill freeze rod, titanium, potassium. It can run on all three polarities. So if you run it on negative, it's okay. If you run it on positive, it's okay. And if you run it on AC, it's okay. Okay? We have 60-12. 60-12s are electrode negative in AC only. So if you run it on electrode positive, you're not okay, right? Okay? So this is what you do. If you ever get an electrode and you don't know which electrode to use, just pull out a book or pull out your phone and look it up. All right? Okay. So now we know that these rods are electrode positive. Okay? Now, being that each one of these rods is a different thickness, right, or different size, the 3/32 being smaller than a 1/8 and a 1/8 smaller than a 5/32, when we run them, we have to run them on different amperage, right? So if I was running this rod, I could turn my machine up to, like, I could start at 150 amps, okay? But if I start this rod at 150 amps, what y'all think's gonna happen? It's gonna burn. The whole rod gonna turn red, and then it's gonna like melt like a Twizzler. Yeah, like a Twizzler, right? So you gotta make sure that you set your amperage correct to the rod that we have, okay? And we're gonna do all of this so you can see the difference in the weld. Now when you are getting ready to weld, you have to put this rod in the electrode holder, grabbing onto the bare metal of the electrode, okay? And that's how the current can flow through the rod to the tip. The tip is also exposed, right? So when you go to strike, that metal tip needs to hit the base metal and then it'll strike, okay? So just as an example, this is what it looks like striking with the machine off, okay? So I'm gonna, see how I tap and then lift up? Okay, you gotta scratch and lift up. You don't wanna tap it and go into it. If you do that, it's gonna stick, okay? But as long as you keep the rod moving, it's not gonna stick. So if I do it like that, it's gonna strike, and then I can have time to lift it up and establish my stable arc, okay? So the rule is, when you strike, you wanna lift the rod, get into the right position, and then you gotta maintain the proper arc length, okay? Arc length is the distance from the base metal to the tip of this electrode, and it's different for each one of these rods, okay? If I have a 3/32 rod, then when I strike, I need to maintain a 3/32 of an inch arc length, okay? So that means I'm gonna be kind of close to it, and I'm gonna maintain that arc length. So when the rod is lit, it starts to burn down like this. So that means I have to constantly feed my hand down the whole time, okay? You don't just strike and hold it in the air, because it's gonna burn up. So if you don't move the rod down, your arc length is gonna get longer and longer and longer until it's out of control, okay? So if the rule is that I have to stay the I have to be as far as the thickness of the rod, right? So this is a 3/32 rod, so I got to be a 3/32 of an inch away from the base material after I strike it. Then when I use a 1/8 rod, how far should I be from the material? I can't hear you. 1/8 of an inch, right? Okay. And then use a 5/32 rod. How far should I be from the base material? 5/32. Pretty simple, right? Okay. Now that's easy to understand, but the hard part is keeping it that distance when you're welding. Okay? So that's what's going to take the practice. So what we're going to do today, what we're going to practice on is just learning how to strike and making a pad of beads. Okay? So we're going to use this. We're going to use this base metal, and we're going to put 3 pieces together like this, and we're going to tack it right here on the joints so that it stays together, and then we're going to run our welds across the surface, straight across, side by side. Okay? So y'all ready to see how that looks? Alright. So now I'm going to turn the machine on, and I'm going to use a 3/32 electrode to tack it together. Okay? So the amperage range I'm going to use for a 3/32 is going to be between 60 and 90 amps. Okay? Once you get over 90 amps, this rod going to be burning really fast. So you don't really want to go too much higher than 90. Okay, but for today, I'm going to set it on 80. Okay, we'll start at 80 amps today with the 3/32. Okay. So first I'm going to tack this together. So to tack it together, I'm going to take it on the edge of this table so I don't weld it to the table. Alright? So I'm going to get my pieces of metal lined up, and then I'm just going to brush it and then tack it. Okay, y'all ready? Didn't want to strike. Okay, so I put a little tack there, right? Y'all saw how calm that was? It was almost so calm that I couldn't get it lit, right? That's because the amps are low, okay? But what you should also understand, let me grab some tools here. What you should understand is that with this 7018 rod, every time you run it, slag is going to form over the weld, okay? And you have to chip that slag off every time, okay? And then you should brush it, okay? Now, the same slag that forms over your weld here is going to form over the end of your 7018 rod, okay? So to get that slag off the end of the rod, you have to tap it like that. That gets that slag off so that when I go to restrike this rod again, it will strike easily, okay? So I tapped it. Now I'm gonna put it back in the electrode holder, and I'm gonna tack the next piece. Notice how I can hold it with my hand, right? I'm not nervous to hold it with my hand because if you wear insulated gloves, you don't have to worry about being shocked, okay? So always make sure you have your safety equipment on, okay? So So now I'm going to take the electrode out of the stinger, and put it back in, and tack the other side. Alright, so now if you put good tacks, your part should stay together and it shouldn't break, okay? Okay. So now I'm gonna show you what not to do, okay? So say you have your electrode. A lot of people they're not sure how to strike the rod, right? So they put the rod in the electrode holder, and then they tap it down like this. All right, you see what's happening? The current is still flowing through this rod, okay? And if you don't take it off, the whole rod is gonna burn up, okay? If you can see that light right there, the current is just flowing through there. See the rod starting to burn up? What you don't do is try to like snatch it away, okay? And then you see that's glowing in there? That means this whole rod was starting to heat up, okay? So anytime your rod sticks, you wanna quickly take the electrode holder off, okay? Whoa. Alright, so look. You should also take the electrode out the holder, but I didn't grab that one with my hand because that thing was smoking. Huh? Yeah, I ain't gonna grab that thing, right? So when I let it out, it kind of was still connected to the jaws, alright? So don't do that either, okay? Alright, so, but I'm gonna stick this one again to show you how to properly take it off, okay? So here we go. I'm gonna stick it, okay? All right, so it's stuck. What I wanna do is just squeeze my electrode holder and take it off like that, okay? And the rod is gonna stay stuck. You let the rod cool down, give it a minute or so, right? Based on how long it was stuck, and then you can just snap it off, okay? So if it sticks, just remove the electrode holder and then take the rod off, okay? Okay. So now we're gonna start welding, okay? I turned the machine up. I'm gonna turn the machine up to 90, because I need a little more heat, okay? And this time I'm gonna weld correctly, okay? So watch, I'm gonna strike. Well, before I do that, let me show you what I'm gonna do. So first, I'm gonna strike the rod by dragging it across the surface. Then I'm gonna pivot my rod up, move it to the proper location, and then start welding across. Okay? So. And when I get to the end, and just snap it off. Okay? Could everybody see that kinda? Yeah? Okay, then always take your filler rod out of the electrode holder before you set this down. Then you're gonna chip the slag. And then you have to brush your weld. Alright, and that's how you strike the rod and run the rod. Okay? Now that was a 3/32 rod. Now I'm going to up in size to a 1/8 rod. Okay, so what should I set the amps to for 1/8?
120, 125.
Okay, yep. So in a flat position, I can run this electrode at about 120, 125. So I'm gonna turn my machine up to 125. I'm gonna put in my electrode holder, and I'm gonna run this right beside that previous weld. Okay, just like this. Pop that off. Okay, take your electrode out before you set the stinger down. Okay. Just like the last one, we're gonna chip. Then we're gonna brush. This weld is a little bit larger than the last weld, right? Because we used a bigger filler rod. Okay. And if we switch to 5/32 rod, what was the starting? 150, right? So let's turn that up to 150. Okay. And we're gonna run it. Okay. And I'm just demonstrating so you can see how they look and how aggressive they are, okay? Here we go. Take that electrode out before you set your electrode. And y'all see how easy I'm chipping this slag? It does not take all of that loud banging that you normally hear in a weld shop, right? If your weld is smooth, it should chip off and then we brush it, okay? So that's pretty much how we strike and run the rod, okay? So any questions about that? No? Okay. This is on 70-18 practice. Anybody, so why don't somebody come and practice or show me how you would strike, and then we can see if you do anything incorrectly. All right? Okay, so I'm gonna tell you, we're gonna start with 1/8 rods. So what you have to do to the machine? Turn it down to how much? 125. Okay, good. Then I want you to take the 1/8 electrode. And which one is the 1/8 electrode? That is the 1/8 electrode. Use a new one. There you go. Good. There you go. And I want you to put your weld. You don't have to put yours beside mine. Put it lower so we can see what happens, okay? Okay. It's not bad, okay? So go ahead and dip it and brush it. I always like to work from one side to the other side. And you can hold it with that. Hold that plate. Got some slack. You always gotta get all the slack. And let's brush it real quick. Okay. So now when we look at that weld, right? It's not as consistent as we would like it to be. So does anybody know why? What happened?
Long argument, a whole lot. And stopped long argument, dipped into it. Travel speed wasn't consistent.
All right. Very good. So what we observed was that when he first struck the arc, right, he was a little bit long. So it looked like the metal was balling up on the end and then dropping down to the surface. So that's an indication that you're too far away. Okay, that means your arc length is too long. Okay, and then as he progressed through, we noticed that he would get close, but then he would wait a second and it would burn up. Then he'd get close again, and it would burn up, right? So that's something you got to be. That's your arc length has to be consistent. So as it's burning, you can't wait for it to burn up. You have to steadily move that rod down the whole time. Okay? So then when we got around this area, you kind of put the rod very close to the puddle, right? Probably less than 1/8. It still continued to run, right? But you have to maintain the proper arc length, okay? And then the other thing we notice is the pattern, the shape of the ripples in the well. They are like V-shaped, okay? And what that means is that you're traveling too fast. Your travel speed is too fast when you have V-shaped ripples or U-shaped ripples, okay? They should be more circular or oval, okay? That was not bad though. You got all the way through the joint pretty good, okay? So
Better than my first time.
that's pretty good, right? For a first time weld.
I can show you some Bitman.
Okay. How about you? You want to try it? Come on, try it for us. And let's see if you do anything wrong that we could talk about, okay? Yeah, and leave a little gap between there so we can clearly see it, right? Okay. All right, let's stop there for a second, okay? So let's talk about what just happened, okay? So first what happened was when you struck this rod, right? You struck it and you went like this. 1, 2, 3, 4, right? Well, let's look under there. Every time you did that, you dropped a little piece of metal up here, right? And you put a defect up here called arc strike. Okay? Anytime you believe an arc strike in a location where you're not gonna weld, that's a defect. Okay, so you don't want these arc strikes on your material. Okay, what they create are weak points. Okay? And then what you also did, you came in with a real steep work angle. Okay, your angle was way down here like this, right? So really all the pressure of the rod is pushing and spattering out. And you had a little bit of long arc in there, right? Y'all observed that too? All right, so let's talk about it. When you strike the rod, you want the rod to be perpendicular to the part with a slight drag. Okay, so it's gonna be like this, strike, go back over where you just struck, and then start depositing weld. Okay? But notice, the rod is perpendicular to the part with a slight travel angle. Okay, about 10 degrees. Okay? You wanna try again? Yeah. Okay. So what you gotta do, since we already struck that rod, what you gotta do first? So now I want you to correct your angle. Let me give you a quick tip, right? Look, if you take this rod, if you're welding in a flat position, and you take this rod, most of the time people want to put the rod in here like this, right? That's pointing straight out from the electrode holder. So in order to put it in the right position, I have to rotate the electrode holder all the way up like that, right? Okay? But if I take this rod and just aim it down like that, it's much easier to get it into the correct position. Look. You see how little of a change I gotta make? And it'll relax in my hand and stay in the right position. So you always wanna angle that rod down when you're welding in a flat position. It'll help you maintain the proper work and travel angle. All right? So here, I'm gonna let you do it. Okay, good stuff. There you go. Good. that's exactly how you release a stuck rod, okay? See how he quickly took it off the electrode holder? That way the rod doesn't burn up. Then you let this cool for a second, and then it'll pop right off, okay? Try that again. Now, sometimes the flux, let's see that. Sometimes that flux will break off the end of the electrode, okay? And if there's no flux on it, it's going to be more likely to stick, okay? So just be anticipating it to stick, okay? Stay close, stay closer, right there. Stay that close the whole time. Stay close. Yeah, be close. Be close. Think of me saying that the whole time. Good. Okay. That was not bad. Okay. That was better than the first time, right?
Yeah.
Okay. So let's see that. So we're gonna take that rod out, right? Now. All right. So. Brush it now. Alright, so he made it all the way across this time. And that's not too bad, but he did do some incorrect things, right? Okay, so what was incorrect that time is that I kept telling you to get closer, and you did what I asked you to do, but you got a little too close. Okay, so what you did is when you were long arcing it, I told you to get closer, and you got closer, and then you kind of rested it onto the surface of the material. The rod is still going to run, right? But then what it does, it makes your bead very narrow. You get a narrow shaped bead, okay? And our goal is to deposit as much metal as possible. So if the bead is narrow, we're not achieving that goal, right? Okay, so the key thing is to maintain the proper arc length, okay? And then the other issue was his travel speed, right? It was pretty fast, right? So sometimes when we start to weld, we just want to hurry up and get through the joint and finish it, but we don't want to rush it. So we got to make sure we're maintaining a consistent travel speed that's allowing us to put the proper size weld down, okay? So let's have you weld for us. Okay. Alright, so now we'll have our experienced welder show us his method. Okay? Using a 1/8 rod.
I go right to left.
You go from right to left. Right
No,
right
you
here.
can see where you're good.
Okay, you do it the way that you do it. Let's see. Okay. Yeah, make your own. Yep. at that. You can look at that weld before we even chip it, and you can see how straight that weld is. That means he was very consistent. Okay? Now, I'm right-handed, so I normally go from the left and to the right. Okay? For me, it's easier to see the puddle as I'm dragging the rod this way. I can see the puddle that way. But there's not the only way to weld.
Because
Go ahead.
there's two ways to look at it. You know, you go left to right, you're focused on your puddle. You go right to left, you're focusing on where you're traveling. So, and you normally don't do right to left till you get more experience and know what's going on with your puddle all the time. You know, you gotta, because then you'll have to pay, once you feel it,
Yes, so he has experience. So he's already got control of his arc length. He's already got control of his travel speed. So he's able to pull that rod from the right to the left, even though he's right-handed, right? So people will tell you that you got to do it this way or you got to do it that way. All you really got to do is put the weld in there correctly. All right, long as the weld is right, that's what matters, okay? So now we're going to chip it. But you can already see that his weld is so smooth that it's just going to lift right off. Look at that, okay? Let's see. Here we go. And look at that. It's a beautiful weld. And see, it's not the way that I would put the weld down, but it achieved the goal, so it's okay. All right? So you want to get the fundamentals of it, and then once you understand how it's working, you can start to do it the way that's best for you, okay? So it's all subjective to you, okay?